Good afternoon, everybody. Thanks for coming. Hope you guys had a great reInvent so far. So my name is Venkatesh, and I'll be presenting this session with Marco, who's my colleague. We are both senior product managers with the Amazon Rekognition team. So let's look at what we're going to talk about in this session today. So first, we're going to talk about what Amazon Rekognition does today. We're going to go through some of the recent announcements that we have made and the features we have added. And we'll also talk about some of the best practices to get the best out of these features. Then we'll also talk about some cool customer use cases, and that's my favorite part of the presentation. We see some really cool stuff coming out of what our customers are doing with Rekognition. And in the end, we'll have a small demo to showcase some of the capabilities. So let's dive in. So Amazon Rekognition, as most of you probably know, is a deep learning-based, easy-to-use service for image and video analysis. Amazon Rekognition image helps you search, verify, and organize millions of images in a day. And yesterday, we launched Amazon Rekognition Video, which also now allows you to get motion-based context out of video. And you can use videos from either S3 or through a live stream. So now let's look at what Amazon Rekognition Image can do today. So today we have 6 capabilities. The first one is object and scene detection, which, given an image, tells you what's in it, tells you the objects and scenes. The second one is facial detection and analysis, which, given an image, finds the faces in it and also tells you different attributes about the faces. Then we have facial recognition, and it doesn't show it here, but we also have verification, where you could search for identities and build collections or databases of faces and search against that. Then we have unsafe image detection, or formerly called as image moderation, which will allow you to detect explicit and suggestive adult content in images. And then there's celebrity recognition, where you can automatically identify hundreds and thousands of famous people or celebrities. And then finally, there's text in image, which is for detecting and recognizing text in real-world images. So yesterday, as I mentioned, we launched Amazon Rekognition Video. And besides giving you some of the features that you just saw with Amazon Rekognition Image, which is object and scene detection, facial detection, celebrity recognition, and unsafe, in this case, video detection, I would like to call out a couple of things that we have added to the video analysis, which is pretty different. So the first one is, along with the object and scene, we also detect activities. Now, activity detection requires understanding the context of what is happening over a bunch of frames. So this could be things like a person blowing a candle, somebody playing a guitar, or a baby crawling. So these things require models to be trained to understand what's happening across a series of frames. So now we have added that along with the objects and scenes that you see for images. The second one, which is new, is person tracking. So in a video now, you can find different people and then track them throughout the duration of this video. And even if people are crossing each other, or they go out briefly and come back in, we'll still manage to track them. And the third one is real-time live stream video processing. And we do this today through Kinesis video streams. So you can ingest the video through the Kinesis video stream, process it using Rekognition, and then send back the results on the stream again. And all of these APIs give you data along with timestamps. So now you can figure out what is happening in each segment of the video specifically. So now with these launches, you get the benefits that Amazon Rekognition offered in both image and video. So you get an easy-to-use, deep learning-based service. It's cost-effective. It's scalable. It's all the usual stuff that you've come to expect of a good AWS service. So in this particular session, we'll be focusing mostly on Amazon Rekognition Image. But we'll be happy to take your questions about the video service as well. And we'll take your questions at the end of this session. So please hold on until then. So over the last year, we have received a lot of feedback from customers, and we are constantly looking to add new features based on this. So let's take a look at how Amazon Rekognition Image has evolved over the last year. So last year, around this time, which was reInvent 2016, we launched Amazon Rekognition Image with these 3 capabilities, which was object and scene detection, facial detection and analysis, and facial recognition. What we then heard from customers, especially the people who have a lot of user-generated content, is that they want to be able to detect inappropriate content in images. And nudity or adult content is the most common problem. So in April, we launched that as the image moderation API, which we now call as Unsafe Image Detection. We also heard from customers who wanted to, you could always create a face collection of celebrities and kind of figure out if there's a celebrity in the image, but the list of celebrities is long. And so people were asking us, can you do this for us and just pre-train a model? So in June, that's what we did, and we launched the Celebrity Recognition API. Now, once these were available, the next obvious step was, can you do text in images? And so just last week, we launched this API for detecting text in images, which I briefly mentioned. We also heard feedback about, there's a limitation on a facial detection that it only detected 15 faces, and we wanted to update that. So we also updated our facial detection and facial recognition algorithms, and I'll go into that into a bit more detail later in this presentation. Let's look at the regions in which Amazon Rekognition is available, and this is image. So when we launched, we were available in the 3 regions: US East, US West, Oregon, and EU Ireland. And based on the feedback from our public sector customers who wanted us to be in GovCloud, we added that in June last year. So since we launched this service, we have seen a lot of different verticals adopting it. And the list of customers that we have today, you can see that there are some themes here. If you look at verticals like media and entertainment, you would see names like C-SPAN, Pinterest, OpenInfluence, Scripps Network. And when I say media and entertainment, I also include things like social media in that. There's also a big uptake on things like public safety. So if you look at names like Washington County Sheriff or Marinus or Motorola, those are, or Butterfly, these are all in the space of public safety or even home safety. So there's a lot of good stuff coming out there. If you look at things like photo sharing, we have SmugMug as a customer. And if you look at digital asset management, again, based on images, you want to understand and manage your assets, you have people like Binder. And we've also seen some very interesting use cases which we hadn't really thought of. On the bottom there, you'll see Google Apps, which is, they built an app called Happy Snap, which lets children learn based on snapping a picture, and then they use recognition to understand what's really happening in the picture, what's the object. And so the child can learn this is how it looks, and this is what it is. So we have seen some very interesting use cases come up, which we didn't really think of when we launched this. So let's dive into now each of the APIs. And I want to focus mostly on the use cases, because by now probably you guys are familiar how the APIs work. The first one is object and scene detection. So as I was mentioning, given an image, this will tell you what kind of objects and scenes are there. You get a set of labels with a confidence score for each label. Now, once you get this information, you can easily tag your library of images and generate this metadata. And once you have this metadata, you can figure out what to do with it. You could do search based on certain objects or scenes appearing in the image. You could categorize the data. You could feed this into another ML model to do topic modeling and things like that. So we have seen customers come up with all sorts of use cases here. Let's look at one common use case or architecture that we have seen often with object and scene detection. So as you can see here, if you, for example, had a mobile app and it was putting in images, what you could do is once the image is snapped, you could put it to an Amazon S3 bucket. And as you all know, there's ways to trigger an event in Lambda where as soon as you upload an image, you can trigger the event automatically. And then as soon as that happens, you can use recognition, pass the image to that, and tag that. So all the images that are getting uploaded will then get tagged. And once the tagging information is available, you can go into either persistent storage like Dynamo, or you could put it into Elasticsearch to create a search index. So this is a common, I would say, workflow that we have seen customers do, especially for figuring out what's the metadata and storing it and searching it. One such customer who used this was Open Influence, and they had a very interesting talk just maybe an hour back of how they used Amazon Rekognition to analyze 30 million Instagram posts. And they got about 120 million labels out of it. They took the high confidence labels, and they built a story around that. So earlier, they were using hashtags to figure out what's happening. This is an influencer marketing platform, so they look at what kind of influencers are doing what, and they look at product placement. They look at who's following whom, and they want to be able to quickly search and match the right concepts here. So earlier, they were using hashtags, and now with Rekognition, they were able to catalog these images, figure out what's happening in them, and then use that instead of the hashtags, which improved their visual search tremendously. So that's object and scene detection. Now let's go on to the facial detection and analysis APIs. So this, as I was mentioning, given an image, it will first find the face and the bounding box for the face. But it also gives you a lot of interesting information, which can be used in many different ways. So the first one is demographic data, where you get the age range of the person. So it's an estimated age range. And if you want a single number, you could choose the midpoint of that. We also give you the gender. So if you think of applications of something like this, if you think of retail, for example, you have a lot of people walking into your store, and you want to understand what's the demographic of people coming in. Let's say you're running a promotion, and you want to understand who is it resonating with. Things like that. So that becomes very easy once you have this information available at your fingertips. The second category of attributes is emotions or sentiments. So we detect 7 different sentiments. And you could, again, use this and combine this with the demographic data if you want. But you could use it to do things like, if you're in the hospitality industry, you could look at how is somebody reacting to a particular service. Or if there's an interactive game that somebody's playing, or anything that is interactive where the screen captures the face, you could use this to then analyze the sentiment of what is happening. Or if you just want to analyze the sentiment of a group of people, let's say in this room, if I wanted to take an image and figure out what's the general sentiment of this room right now, so that could also be done with this. The third one is facial landmarks. So we give you a set of landmarks around the eyes, nose, lips, chin. What you could use this for is you could either use it to align the images. You could do things like morphing one face onto another. We've also heard of very interesting applications where if you want to locate, for example, somebody's lips, and you want to color that with a different color. Let's say you have a cosmetics company, and you want to show people how different lip colors look. You could do things like that. So with the landmark information, you kind of know the lay of the land of the face, and then you could do multiple things with that. We also have a set of general attributes which are interesting in their own right. We have things like whether the person is smiling or not. You also get facial hair, so whether somebody has beard, mustache, whether they're wearing glasses. And the interesting one here is something called as eyes open. Now, if you think about this, you could think of applications in, for example, you have installed a camera in a car, and you want to see if the driver is awake, they're alert, their eyes should be open, right? So you could use this very simply to figure out whether somebody's really doing their job and their eyes are open. Same thing could apply to somebody who's operating, let's say, machinery, and the factory safety and applications like that. The last two are pose and quality. So the pose is, as you would imagine, it takes the pitch, roll, and yaw of the face. So you could figure out if somebody is looking straight, or if the head is tilted down, sideways, different axes. And the quality, as it suggests, it can tell you whether the image is blurred or not. So you would want to look for a sharp image, or something which has good brightness. Now, if you look at each of these attributes has good use cases on its own. But you could start putting them together also for some very interesting ideas. So imagine that if you had if you were running a dating website or you were running a social media website where customers upload profile pictures, right? And you want to assist them in figuring out what's the best picture. And people could have different definitions of what's the best picture. Now you as a customer or even your customers could choose different things, and then automatically you could create business rules here saying, let's say for example, I only want the best pictures, so to speak, should have the person is front facing. So you could use the pose for that. The quality of the image is good. It's not a blurred image. You could use the bounding box, which we also return, to figure out the area that the face covers in that image. So for example, you don't want a profile picture where the face only covers, let's say, 20% of the area. Maybe you can keep something like 40 or 50% as the minimum threshold. So as you can see, you can just use this information in any which way you want and create your own business rules and applications. So that's with facial detection and analysis. As I was mentioning, we had a limit of 15 faces per image. And so last week, we announced this new crowd mode where now you can detect up to 100 faces in the image. Now, as you can see, and this is not very clear, but there's actually bounding boxes around each of the person's faces here. They're in gray, so apologize for that. But as you can see, this is now opening up new applications. If you want to do crowd sentiment analysis, let's say you are the owner of a sporting venue, or you have concerts, or you have things like that. Or if you have a very large retail store where, again, you're running a busy promotion, a lot of people are coming in, and you need to analyze all of that at scale. So with this, you can do that very easily. And 100 is quite a lot, but you could always, if you need to go even higher, you could stitch together different images. But now all of this is fairly easy to do with the same API call. There's absolutely no change. You just get more faces. So I've been mentioning this use case a couple of times. This is how you might actually do it. So let's say you want to study the demographics and sentiments of in your retail store, especially in busy periods when you're running a promotion, or to understand how particular aisles have a distribution of who's coming. Maybe you want to understand that, or you find that when I run this promotion in this particular aisle, this product has mostly women aged 40 to 60 coming to it, or this is appealing to children. And now if you want to do it in a busy period, you could now use the crowd API that we have to do it for up to 100 people at once. So now what you would do here is you would just take the image using a mounted camera. You would pass that to Rekognition, and then once you have the information, you can put that in something like Redshift. You could do analytics with QuickSight, visualize the different demographic distributions or age ranges and things like that. So it's a good way to put together different AWS services and get what you want out of that. So now let's talk about facial recognition and face search. So face search on Amazon Rekognition is a 3-step process. First, you have to create the collection, as we call it, which is a database where you can store the actual faces. So once that container is created, there's a process to index faces into that. So for example, you have 10,000 people that you want to put into the database. You would have to take those images and then run the indexing operation, and now they go into the collection as face vectors. Once you have that, your collection is loaded, it's ready to go, and then the third step is now you can run a search against that. So this was launched last year, and we have seen a lot of good applications for this. But what people asked us for was, can you make it much more scalable? I have lots and lots of faces, and I want to search them very fast. So what we launched last week was real-time face search against tens of millions of images. So if you think about this, now you can put tens of millions of faces into a collection, and you would still get search results back in real time. And that is pretty powerful for certain applications where the scope of search is so large that, and time matters. And so this is why we built this. We heard this feedback from customers that we have lots and lots of faces, and we want to search them very fast. So let's look at one of our customers who actually built a very cool application with this. And some of you might have attended this talk earlier by Chris at Zima, who's with the Washington County Sheriff Office. So the Washington County Sheriff Office is a first responder to 911 calls. And what happens here is, they have a list of previous offenders. So they have a huge database of mugshots of people who were apprehended for different crimes. And it's 300K images. It's a lot of images to search through. So once they get a report that somebody is doing suspicious things, or it's potentially a sighting of a known criminal, the way it used to work was they used to have PDF bulletins which used to go out to their officers and detectives in the field. And those people, if they remembered that they'd seen somebody, or if they knew somebody else who had seen this, they would just communicate. And it was very difficult and slow to actually do this. Now with face search, what they were able to do was load this up into a collection. They built this in like 2 weeks. And then the time to find this, such a person, that came down to seconds, right? And there's a very interesting use case that Chris mentioned in his presentation, and I'm going to borrow that because it's just so cool. So this person was actually captured on a store cam, and he was suspected of taking I think $1,000 worth of stuff from a big box hardware store, and he didn't pay for it. He just went off. And so once they got this image, now with Rekognition face search powering that, what they could do is immediately search for him against those 300K indexed faces. And within seconds, they found this match of this person, and of course his name was also present. Now, once that was available, they were able to send that to the detective in the field saying, here's the person, here's his name. And what that detective did was he went to his Facebook profile, and here's the picture he found. Now, as you can see, he's wearing the same hoodie, right? And this person, as luck would have it, has a weird look on his face where it's, it looks like he's smirking. So it's a very distinctive picture. So they could ID it pretty quickly, and then the arrest was made, right? So this has happened in the first week, like 3 days after they put the system in place. And now, as you can imagine, the real-time face search would keep enabling such applications, even if their list of previous offenders grows to millions of people. And in the field, speed matters. Like, Chris himself said this, a few seconds in the field can save a life. And in this case, it's very humbling to see the kind of impact that customers are able to have, and we can play our small part in that as well. There's another use case here which is similar in its scale and its impact, and this is by Marinus Analytics. So Marinus it's a CMU-based company, and I'm from CMU, so just a shout out there. Now, Marinus uses artificial intelligence tools to help law enforcement fight against sex trafficking. What happens here is a lot of minors are captured and they're trafficked for sex, and that's a pretty horrible thing to happen to anybody. And the list of missing people runs into millions. Now, again, earlier law enforcement didn't have any way, and what these people do is they actually post ads online, and people like Marinus have access to the ads, but it's very difficult to make an ID saying that this is the actual person who was missing. So what they did was, again, they used face search, and they indexed all these millions of missing people into that. And as with Washington County Sheriff, within a few days, they were able to immediately find matches and they were able to save victims. Like in this particular case, there's a social media picture of a victim available saying that this person, here's the Facebook picture, and they're actually missing. And they looked at against the collection of millions of pictures taken from the ads, and they're able to make a match, and officers were able to go and save her. And within the few weeks after that, there were more and more people who got saved due to this. Another such use case for face search is in the media and entertainment space. where C-SPAN, as most of you might be familiar with, they do a lot of programming of the government. They have a lot of politicians showing up in their feeds. And one of the things that they had to do was to figure out which video clips contain which politician. And so earlier, they had this process as a completely manual process. Somebody had to go through all this video and figure out when is Donald Trump showing up, or when is Sean Spicer showing up in the clip, and also search for that. So it was a very tedious process. So what C-SPAN was able to do was quickly index all these politicians, and as you can see there, it's 99,000 identities. And what you can do here is for every identity, which is a single person, you could have multiple images of that person from different angles just to improve the accuracy. So they did that, and again, they were able to build this in a couple of weeks. And once they put this into production, they were able to save 9,000 hours of labor every year. And that's pretty phenomenal impact. So now that we have looked at some of the use cases that people are doing with face search particularly, let's look at some best practices as to how you can get the most out of faces. And there are there's some tips and tricks which you can use. So the first one is about the size of the face. So I mentioned the crowd mode, where you have up to 100 faces. Now, as you can imagine, as you pack more and more faces into the picture, it gets smaller. Or if you have a security use case where you have a camera which is mounted overhead, the faces might get smaller and smaller based on that. So there is obviously a limit, because beyond a point, there's not enough information in the image that you can capture it. So we recommend that the face be at least 5% of the shorter image dimension. So if you have, for example, a 1080p image, you would want the face to be 50 pixels by 50 pixels, around that size, and we'll find it. Technically, we can go lower, but if you just want to find the faces and count them, that's still good. You could do that. But if you want to do facial recognition based on that, we would recommend using larger faces, because then there's more information, and the quality of the features that we extract from that would be much better. The other tip here is for live use cases. So for example, if you have somebody uploading a picture on a website, and you want to quickly give them feedback or do some of the business rules that I mentioned before based on facial analysis, and give them a result. So it's an interactive setup. You don't want it to take too long, because the customer experience will suffer. So what you can do there is, as you might know, Amazon Rekognition takes images both from S3 as well as raw bytes. So instead of writing it to S3 and kind of reading it back, that's a lot of round trip time. You could just send the bytes directly, and any live use case would benefit from this, because the speed would then be higher. The other thing for speed is you can play with the resolution. So for example, if you have a use case where you were building a smart check-in system, where people are walking up in a line, you have a controlled environment, you take a close-up shot of the person, and the face is present, and you're just identifying that this person is actually one of the whitelisted people or not, you don't really need an HD image for that. The face is occupying probably 80% of that. It's a close-up shot. So what you could do is, in such cases, you could opportunistically reduce the resolution, and if the image is small, then it will get processed faster. It's not a linear scale, but definitely you can expect that progression. So this is, again, for the facial detection piece. For the facial search piece, we already have vectors, and we have done a lot of work to make sure that the speed remains almost constant, even though you keep increasing the number of searches that you have to do. The other thing that we see often is if you have use cases where there's a lot of variation in the same person's appearance, and you don't have too many people. So let's say you have only 100 people that you are interested in, but each of those 100 people could have a lot of variations in their face, and you want to be able to still accurately match that. So what you could do is you could create separate collections for each of these people. So let's say you have these 100 people, you create the 100 collections. You could put all the variations of one person in one collection. So essentially, the collection maps to an identity. And then you would have to do some work to parallelly search across these collections and aggregate the results. But if your application has that requirement of very high accuracy under high variability for individuals, you could do something like this. And finally, I want to touch upon face model versioning. This is something we introduced recently. So at Amazon Rekognition, our scientists are always working to improve the models that we have based on feedback, based on the use cases that we see. And we put that out in the form of new models, right? Now, when we put a new model in, it could have a different architecture, it could have different dimensions and things like that. So there's no guarantee that it could be compatible with the previous version. And that's why we have introduced this concept of versioning, where every time we have a new model, the version would be updated. Now, if you already have a collection using a certain model version, you obviously don't want that to suddenly change one day when we update the model, right? So what we do is we don't move you automatically to the new version, because that probably will behave differently, and you might have thresholds set up and other things set up based on that version. So we allow you to do it at your own pace, where you'll have to reindex it into the new version, and that's at your pace. So if you feel you're ready, you have already tested it out in a small scale, and now you want to run it to production, you could now create a new collection. And the way it would work is any new collection would default to the latest version, and if you have an old one, it'll stay there. So that allows you to manage what you want to do, but if you're a new customer coming in, you always get the latest and the greatest. So that's for the best practices, and now I'd like to hand it over to my colleague Marco to take you to the rest of the presentation.
Thank you, Venkatesh. Hi, everyone. So one of the other capabilities that we added since last reInvent is unsafe image detection. So in lots of use cases, our customers are asking for ways to detect explicit or suggestive adult content, right? But sometimes knowing that content is explicit or suggestive is not enough. So what we provide is a hierarchy of labels, where for explicit you may have sexual activity or nudity, and in suggestive you want to have the level of detail that tells you it's female swimwear or male swimwear. So the way it works is you get these labels associated to your image, as usual with a confidence score. So the use cases that we see our customers applying unsafe image detection to are, if you think about for example, dating apps. For example, Soul's platform, which actually enables dating apps to be built via a cloud-based customizable platform. In this case, what you can see is, again, a similar architecture to the one we saw before, where a user submits an image, it gets stored on S3, and then Rekognition gives labels that tell you it's explicit content, it's suggestive, it's female swimwear, and this way you can send only the images that you consider to be monitored and manually reviewed to a moderation workforce, which allows you to dramatically reduce the cost of your moderation workforce. So platform applies this to moderating images, to filtering out users that they don't want to be able to, after they're updating many explicit images. And we see lots of usage in dating apps, as I said. Celebrity recognition. So we heard this, the need for this feature multiple times from our customers, where they were building their collections of faces for different celebrities. So with celebrity recognition, you can recognize actually thousands of global public figures across business, media, entertainment, politics, sport, across a variety of domains. And what this enables you to do is, for example, in your digital assets, images, and as of today also on videos, you can go and look for specific celebrities For example, if there's a piece of news about a specific celebrity, you can quickly look up in your catalog of images and videos and say, OK, give me only the images and videos that have the celebrity. And we also provide some additional metadata, such as the IMDb link for that celebrity. As of last week, we announced text in image, which is something the customer had been asking for since the beginning, since we launched Rekognition. Text in image allows you to detect text in real-world images, which is called, in science, in research, it's called text in the wild or text in natural scenes. And it can be text completely in the wild, such as street signs or license plates. It can be text on screen. If you think about captions or ads or news in your videos, or it can be text, for example, on social media images. If you think about stylized quotes over landscapes or on your family picture. Text in image recognizes both words and lines. For example, the box thing in this image will be considered as a line. And you'll get this hierarchy of lines and words. You will get the actual text label, so the characters, and the bounding box. In this case, it's also oriented. You see, it detects text with horizontal alignment plus minus 30 degrees approximately. And it works not only on printed text, but also on heavily stylized fonts, almost handwritten. And in this image, you can see that it's both horizontally aligned and stylized almost 30 degrees oriented text. What this enables you to do is to enrich your catalog of images with text information. In this case, you have a picture of Seattle. When there is text overlaid close to the Space Needle, what you can get from Rekognition is not only that there is mountains and the Space Needle, but also that there is the actual word Seattle. You can persist this information in DynamoDB or index it with Elasticsearch. So the next time your users come and look for the word Seattle, you can pull up this image and present it to them in a recommendation engine, for example. Another use case that we're enabling customers to implement is license plate recognition or recognition of vehicles or products based on numerical codes. If you think about recognizing a bottle based on the price or based on specific features on the label. So an application that we will see, like an architecture that we will see here, is actually streaming and capturing frames from cameras on the streets, analyzing them with Rekognition, and detecting there is a license plate, that is the number, and then persisting it in DynamoDB or S3, and then notifying maybe the user. And you can match maybe the number with a table that says for this vehicle, this is the owner, this is the model, and whatnot. A few best practices for text in image, since it's a new feature that we released. Focus on real-world images. So this is meant for text in the wild, again, social media images. So in media use cases, for example, text on screen, rather than documents. Focus on specific areas of interest. So for example, in the license plate case, if you know that you have a fixed camera and cars always roll on a certain part of your screen, just send us the crop images. It increases the accuracy of the text that we detect. Test multiple orientations. So right now, as I said, we detect text with plus or minus 30 degrees. But think about floor plans. If you're in real estate, when you have text on 4 different every 90 degrees, we recommend you to test it on again multiple orientations to extract the text from various degrees. We have customers that are interested in only numerical codes, others that want only English words or Spanish words. By the way, something that I forgot to mention is that it detects every Latin script. So A through Z, it doesn't know that it's English or Spanish, but anything that basically looks like a Latin script, and A through Z or a number or a common symbol is detected, and you can extract it. If you're only interested in spell checking, in dictionary words, use a spell checker for the language that you're interested in, send the output there. Or as of yesterday also, you can use the Amazon Comprehend APIs. So you can send the extracted text from images to detect the language, to extract entities, extract, they do topic modeling, key phrases, or sentiment analysis. I wanted to do a quick demo of see how this thing works. I want to do a quick demo, just run through the console for those of you that are not familiar. So this is the AWS Management Console. For Amazon Rekognition, on the left you see all the image APIs and functionalities, and down here you find video analysis. I'll quickly go through all of them. For objects, you get basically all the labels on the right, skateboard with confidence score, and here on the left you get the actual API response, which it's usually a JSON output with the label and the confidence, and they are ranked by 0 to 100. From 100 to 0. Image moderation, which is unsafe image detection. In this case, it doesn't detect any unsafe content, so the API and the output is empty. In this case, it will detect female swimwear as a subcategory of suggestive content, and you find this category with parent name that allows you to see to capture the hierarchy. Facial analysis, again, up to 100 faces. It gives you all the landmarks and the attributes on the right. So it looks like a face, appears to be female, the age range, smiling. If you scroll down, actually in the API response, you have all of them. So you have the quality of the image, you have the sentiment and the emotion, and you have at the very end, then you have pause like roll, yaw, and pitch. And if there are 15 faces, you get this information for all 15 faces. In this case, for example, there are 3, and you get them for all of them, one at a time, right? And so the API will return all this information. Celebrity recognition is very similar. It will tell you that this is Jeff Bezos, the IMDb link in case you want to capture additional metadata, and the bounding box, so the geometric coordinates of where the face is in the picture. Face comparison, I'll show you face search on a larger collection of faces, but the idea is you have 2 pictures, and it tells you between the first and the second image, all the faces that match, they're similar versus those that are not. So in this case, the girl appears with 93% confidence in both pictures, but there is no similarity with the other 2 faces. And the recently announced text and image, which gives you, in this case, a list of objects. Any object is a word or a line. So in this case, I don't know if you can see it, but it's the first one is it. It tells you the geometric coordinates, both of the bounding box and as a polygon. So you get the 4 vertices, and you get the ID, so that in this case it's one line when it's also only one word. So it's in this case it's the only word in the line. But if it was, for example, but keep, you have the ID of the line, and then you have the ID of the 2 words that match the parent line. So this kind of layout information. And I wanted to show you very briefly, I don't know who of you had the chance to look at video analysis, but it looks like this. In the sample video we have, Jeff and Werner. In people detection, it tells you that, for example, Werner shows up only from this frame onwards, and Jeff disappears as of this frame, and it's only Werner. So you can get this kind of the same face and celebrity and unsafe image detection information that before you would get on an image, now you get it at different timestamps on a video for your store videos. And the final demo I wanted to quickly show you is face search. It works. So in this case, we created a collection with all AWS employees, and this is a picture of me without a beard a couple of years ago, and it matches, and it tells me that out of all AWS employees, that's the match with me, and there are other people that look like me or look like. So with and without beard, you have Venkatesh, his graduation, so with headgear or without headgear or different glasses, you can still match. We have Jeff Barr, who recently is into pink hair, and it wasn't some time ago. So you can detect also different hairstyles or different hair colors, and just out of popularity, I had to throw Werner. And also, it's a very popular face. I don't know, but you see other matches, but there is a difference in the confidence level. And finally, James Hamilton. It didn't change much, but that's how it was detected. If you want to get started, you probably already know about these resources, but definitely the Rekognition Get It Started page, developer resources, and the AWS AI blog. We have solutions architects and customers publishing their stories or architecture and CloudFormation template about how they're using Rekognition. This concludes our presentation. We'll be off stage if you want to come ask us questions. We'll take them on both sides, but thank you.